mapped statements in MyBatis. Now we are focusing on mapped statement. Map statement can hold any SQL statement and can use parameter maps and result maps for input and output. Here you can see how to communicate SQL written in XML, SQL map.xml in MyBatis with DB. Uh, in the way of programming using existing JDBC, SQL statements were written in the program source, but using MyBatis, the SQL statements are separated from the program and written separately in XML file. This reduces the burden of programmers programming when using existing JDBC. In addition, if the user wants to change the SQL can be changed freely because the user only needs to change the SQL statement in the SQL files in the XML file rather than modifying the program as before. When user writes the each SQL statement for CRUD in SQL map.xml XML file and writes these files in SQL map.config.xml file, it's automatically create mapped statements objects through MyBatis API and execute SQL statements in DB through it. Int or integer and returns a hash map keyed by column names mapped to raw values. As an example 2, we can consider the this annotation type intercept, the annotation that specify target methods to intercept, and this is in package org.apache.ibatis.plugin. This annotation type signature, the annotation that indicate the method signature. The type element is returns the Java type, and method returns the method name, and args returns Java types for method arguments. And here implements pre-processing if needed, and implement post-processing if needed here, before and after invocation that proceed. As a class mapped statement, this is in the package org.apache.ibatis.mapping. Now we are considering exploring mapped SQL statement. Here is an example of XML based map statement that would satisfy the SQL session calls. At this point you may be wondering what exactly is being executed by the SQL session or mapper class. The topic of mapped SQL statement is a big one, and that topic will likely dominate the majority of this talk. But to give you an idea of what exactly is being run, here is a couple of examples. In either of the examples here, the statement would have been defined by either XML or annotations. Let's take a look at XML. The full set of features provided by MyBatis can be realized by using XML based mapping language that has made MyBatis popular over the years. If you have used MyBatis before, the concept will be familiar to you, but there have been numerous improvements to the XML mapping documents that will become clear later. Here is an example of an XML based mapped statement that would satisfy the above SQL session calls. While this look like a lot of overhead for this simple example, it's actually very light. You can define as many mapped statement in a single mapper XML file as you like, so you get a lot of mileage of the XML header and doc type declarations. The rest of the file is pretty self-explanatory. It defines the name for the mapped statement, select block in the namespace, mybatis.example.block mapper, which would allow you to call it by specifying fully qualified name of org.mybatis.example.blockmapper.selectBlock. Here's one of the more trick the mapper classes like block mapper. One second. Oh, here, sorry. Notice how similar this is to calling method on a fully qualified Java class, and there is a reason for that. This name can be directly mapped to the mapper class of the same name as the namespace, with the method that matches this name parameter and return type as the select statement. This allows you to very simply call the method against the mapper interface as you saw above here. But there's again in the following example. The second approach has a lot of advantage. First, it doesn't depend on string literal, so it's much safer. Second, if your IDE has code completion, you can leverage that when navigating your maps SQL statements. A note about namespaces. Namespaces were optional in previous versions of MyBatis, which was confusing and unhelpful. The namespaces now required and have a purpose beyond simply isolating statement with longer fully qualified names. A namespace enable the interface binding as you see here, and even if you don't think you will lose them today, you should follow these practices laid out here in the case of change your mind. Using the namespace once and putting it in a proper Java package namespace will clean up your code and improve the usability of MyBatis in long term. Namespace resolution. To reduce the amount of type in MyBatis uses following name resolution rules for named configuration elements, including statement, results, map, and caches, etc. Fully qualified name, for example, com.mypackage.mymapper.select all things are looked up directly and used it if it found. Short name select all things, for example, can be used to reference an unambiguous entry. However, if there is two or more, for example, com.foo.select all things and com.bar.select all things, then you will receive an error reporting that the short name is ambiguous and therefore must be fully qualified. Here we are considering select in mapper XML files. For example, here the select statement is one of the most popular elements that you will use in MyBatis. Putting data in the database isn't terribly valuable until you get back it out. So most application query far more than they modify the data. For every insert, update or delete, and there are probably many selects. This is one of the following principles of MyBatis and is the reason so much focus and effort was placed on querying and result mapping. The select statement is quite simple for simple cases. For example, here the statement is called select person, takes parameter of type int or integer and returns the hash map keyed by column names mapped to row values. Notice the parameter notation id. This tells the MyBatis to create prepared statement parameter. With JDBC, such a parameter would be identified by question mark in SQL passed to a prepared statement, something like this. Of course, there is a lot more code required by JDBC alone to extract the result and map them to an instance of an object, which is what MyBatis saves you from having to do. There's a lot more to know about parameters and result mapping. Here the attribute ID, the unique identifier in this namespace that can be used to reference this statement. Parameter type, the fully qualified class name or alias for the parameter that will be passed into this statement. This attribute is optional because MyBatis can calculate the type handler to use out the actual parameter passed through the statement. Default is unset. Result type, the fully qualified class name or alias for the expected type that will be returned from this statement. And note that in the case of collection, this should be the type that collection contains, not the type of collection itself. Use result type or result map, not both. Similar JDBC code, not MyBatis. Now we are considering insert, update and delete. The following are some examples of insert, update and delete statements. The data modification statement, insert, update and delete are very similar to their implementation. Here the ID, a unique identifier in this namespace that can be used to reference this statement. The following are some examples of insert, update and delete statements. As mentioned, the insert is little bit more rich in that it has few extra attributes and sub elements that allow to deal with key generation in a number of ways. Now we are considering SQL. For example, here this element can be used to define a reusable fragment of SQL code. That can be included in other statement. It can be statistically during load pace parameterized. The difference property values can vary in include state instances. For example, here SQL fragment can then be included in another statement, for example. I select users here, select ID, sorry. Now we are considering cache here using a custom cache. By default, statement are configured like this, and MyBatis include the powerful transactional query caching feature, which is very configurable and customizable. A lot of changes have been made in the MyBatis 3 cache implementation to make it both more powerful and far easier to configure. By default, just the local session caching is enabled, that is used solely to cache data for the duration of a session. To enable global level caching, simply need to add one line to your SQL mapping file. So here that line is cache, just simply this open open angle bracket cache, then / and then close angle bracket. Basically that is the effect on of one simple statement. It as follows: all result from this select statement or mapped statement file will be cached. All insert, update, delete statement will be mapped statement file will be flushed to the cache. The cache will use a least recently used LRU algorithm for eviction. The cache will not flush on any sort of time-based schedule, that is no flush interval. Cache will store 124 references to list of objects whatever the query method returns. Cache will be treated as a read-write cache, meaning objects retrieved are not shared and can be safely modified by the caller without interfering it with other potential modification by other callers or threads. Note the cache will only apply to statement declared in the mapping file where the cache tag is located. If you are using Java API in conjunction with XML mapping file, then statement declared in companion interface will not be cached by default. You will need to refer to the cache region using @cache namespace ref annotation. All these properties are modifiable through attributes of the cache element. For example, here more advanced configuration creates FIFO cache that flushes once every 60 seconds, stores up to 512 references to result object or lists, and object returns are considered read-only. Thus modifying them could cause conflict between callers and different threads. The available eviction policies are available LRU, least recently used, removes object that haven't been used for the longest period of time. FIFO, first in first out, removes object in order that they entered the cache. Soft reference, remove the object based on the garbage collected state and the rules of soft references. Weak reference more aggressively removes object based on the garbage collected state and rules of weak references. Default is LRU. Flush interval can be set to any positive integer and should represent a reasonable amount of time specified in milliseconds. The default is not set and thus no flush interval is used, and the cache is only flushed by calls to the statement. Size can be set to any positive integer. Keep in mind the size of the object you are caching is available memory resources of your environment. The default is 1024. The read-only attributes can be set to true or false, and read-only cache will return the same instance of cache object to all callers. Thus, the object should not be modified. This offers a significant performance advantage, though. A read-write cache will return only a copy via serialization of the cached object. This is slower but safer, and thus the default is false. Note the second level cache is transactional. This means that it is updated when a SQL session finishes. SQL session finishes the commit, or when it finishes with rollback, no insert, update, insert, delete, updates with flush cache equal true executed. Using a custom cache, in addition to customizing the cache in this ways, you can completely override the cache behavior by implementing your own cache or creating an adapter to their third-party cache solutions. It is important to remember that cache configuration and cache instances are bound to the namespace of the SQL map. Thus, all statements in the same namespace as the cache are bound by it. Statement can modify how they interact with the cache or exclude themselves completely by using two simple attributes. So on the statement by statement basis, by default the statements are configured like this. Since that's the default, you obviously should never explicitly configure a statement that way. Instead, only set the flush cache and use cache attributes if you want to change default behavior. For example, in some cases you may want to exclude the result of a particular select statement from cache, or you might want to select statement to flush the cache. Similarly, you may have some update statement that don't need to flush upon execution. Now we are considering dynamic SQL. If in dynamic SQL, for example, here the most common thing to do in dynamic SQL is conditionally include the part of a where clause. For example, here the statement would provide an optional text search type of functionality. If you passed in no title, then all active blogs would be returns. But if you pass a title, it will look for a title like that for the keen-eyed. Yes, in this case your parameter value would need to include any masking or wildcard characters. Now we are considering choose when otherwise. If neither is provided, let's only return featured block, perhaps the strategically list selected by administrator, instead of returning huge meaningless list of random blocks. Sometimes we don't want all the conditions to apply. Instead, we want to choose only one case among many options. Similar to the switch statement in Java, MyBatis offers a choose statement. Let's use the example here. But how? Let's search only on title if one is provided, then only by author if and then only by author if one is provided. If neither is provided, let's only return featured blogs, perhaps the strategically list selected by administrator, instead of returning a huge meaningless list of random blocks. Now we are considering trim, where, and set. Consider what would happen if we return to our if example, but this time we make active equal 1 a dynamic condition as well. The previous example have been conveniently dancing around the notorious dynamic SQL challenge. Consider what would happen if we return to our if example, but this time we make active equal 1 a dynamic condition as well. What happen if none of these conditions are met? You would end up with SQL that look like this. And what if this would fail? What if only the second condition was met? You would end up a sequel like the sequel that look like this. This would also fail. This problem is not easily solved with conditionals, and if you ever had to write it, then you likely never want to do so again. MyBatis has a simple answer that will likely work in 90% of cases, and in cases where it doesn't, you can customize it so that it does. With one simple change, everything work fine. The where element knows to only insert where if there is any content returned by the containing tags. Furthermore, if that content begins and or it knows to strip it off. If where element does not behave exactly as you like, you can customize it by defining your own trim element. For example, the trim element to where element is prefix overrides attribute takes a piped delimited list of text to override where white space is relevant. This result is the removal of anything specified in the prefix override attribute and the insertion of anything that prefix attribute. There is a similar solution for dynamic update statements called set. The set element can be used to dynamically include columns to update and leave out others. For example, here the set element will dynamically prepend the set keyword and also eliminate any external commas that might trail the value assignment after conditions applied. Alternatively, you can achieve the same effect by using trim element. Notice that this case we are overriding suffix while they were still appending a prefix. We can consider for each, for example, here. Another common necessary for dynamic SQL is we need to iterate over collection. Often to build an in condition, for example, here. The for each element is very powerful and allows you to specify a collection, declare an item, an index variables that can be used inside the body of the element. It also allows you to specify opening and closing strings and add separator to place between iterators. The element is smart in that won't accidentally append extra separators. Note, you can pass any iterable object for example list, set, etc., as well as any map or array object for each as a collection parameter. When using iterable or array, index will be the number of the current iteration and value item will be the element retrieved in this iteration. When using a map or a collection of map.entry object, index will be the key object and the item will be the value object. This wrap up the discussion regarding XML for each here. We are considering now script, for example here. For using dynamic SQL in annotated mapper class, script element can be used. For example, here we are considering bind. For example here, the bind element lets you to create variable out of OGNL expression and bind it to the context. For example here, now we are considering multi-DB vendor support. Have a look at the following example. If the database ID provider was configured, underscore database ID variable is available for dynamic code. So you can build different statements depending on the database vendor. Have a look at the following example. Now we are considering pluggable scripting languages for dynamic SQL. Instead of changing the default, you can specify the language for a specific statement by adding a lang attribute as follows. The interface lang driver in package org.apache.ibatis.scripting. Starting from version 3.2, MyBatis support pluggable scripting languages, so you can plug a language driver and use that language to write your dynamic SQL queries. You can plug a language by implementing language driver interface. Once you have custom language driver, you can set it to be the default by configuring it in mybatis-config.xml file. Instead of changing the default, you can specify language for the specific statement by adding lang attribute as follows. Or in the case you are using mappers, you can use @lang annotation. You can use Apache Velocity as a dynamic language. Have a look at the MyBatis-Velocity project for the details. All the XML tags you have seen in the sections are provided by the default MyBatis language that is provided by the driver ogda-apache.ibatis.scripting.xml tags.xml lang driver, which is aliased as XML. Now we are considering SQL execution methods in SQL session, and in SQL sessions, a cursor offers the same results as a list, except it fetches data lazily using an iterator. These methods are used to execute select, insert. Now we are in statement execution methods. These methods are used to execute select, insert, update, and delete statement that are defined in your SQL mapping XML file. They are pretty self-explanatory. Each takes the ID of the statement and parameter object, which can be primitive, autobox, wrapper, a Java bean, or poacher, or a map. The difference between select one and select list is the only that select one must return exactly one object, and object or null and none. If there's more than one, an exception will be thrown, and if you don't know many objects are expected, select list. Expected to use select list. If you want to check the existence of an object, you are better off running count 0, 1. If you want to check the existence of an object, you are better off running 0, 1. The select map is special case in that it is designed to convert a list result into a map based on one of the properties in the resulting object, because not all statements require a parameter. These methods are overloaded with versions that do not require one parameter object. Value returned by insert, update, and delete methods indicate number of rows affected by this statement. Cursor offers the same results as a list. It fetches data lazily using iterator. Finally, there are 3 advanced versions of select methods that allow you to restrict a range of rows returned or provide custom results handling logic, usually for every data sets. Row bounds parameter causes MyBatis to skip the number of records specified, as well as limit the number of results returned to some number. Now we are considering batch update statement flush method. This method can be used when executor type is executor type.batch. The flush statement, the list batch result flush statement method flushes batch statement. This is in the interface SQL session, and which is in the package org.apache.mybatis.session. There's a method for flushing executing batch update statement that I stored in JDBC driver class at any time. This method can be used when executor type is executor.batch. Here, this one. Now we are considering transaction control methods. However, if you are using JDBC transaction manager managed by the connection instance, then the 4 methods that will come in handy to use. Void commit, the flushes back statement and commits database connection. Note that database connection will not be committed if no updates and deletes inserts were called. To force the commit, call commit boolean. Void commit boolean force. Flushes batch statement and commit database connection. Void rollback discards the pending batch statement and rolls the database connection back. Note that database connection will not be rolled back if no updates, deletes, insert were called. To force the rollback, call rollback boolean. Rollback boolean. Void rollback boolean force. Note that boolean discards the pending batch statement and roll back database connection back. Note that the database connection will not be rolled back if no updates, deletes, inserts were called. These are in the interface SQL session and in the package org.apache.mybatis.session. There are 4 methods for controlling scope of a transaction. Of course, these have no effect if you are chosen to use auto commit or if you are using external transaction manager. However, if you are using JDBC transaction manager managed by connection instance, then 4 methods that will come in handy are these. By default, MyBatis does not actually commit unless it detects that the database has been changed by a call to insert, update, delete, or select it affect data enabled. If you are somehow made changes without calling these methods, then you can pass through into commit or rollback methods to guarantee that they will be committed. Note that you still can force sessions or in auto commit node, or note that using external transaction manager, most of the time you won't have to call rollback, as MyBatis will do that for you if you don't call commit. However, if you need more fine-grained control over the session where multiple commits and rollbacks are possible, you have a rollback option there to make that possible. MyBatis-Spring and MyBatis-Goose provide declarative transaction handling. So if you are using MyBatis with Spring or Goose, please refer to their specific manuals. Now we are considering local cache. You can clear the local cache at any time by calling void clear cache method, clears local session cache. This is in the interface SQL session and in the package org.apache.mybatis.session. MyBatis uses 2 caches, local cache and second level cache. Each time new session is created by MyBatis, create a local cache and attach it to the session. Any query executed within a session will be stored in the local cache, so further execution in the same query at the same input parameters will not hit the database. The local cache is cleared upon commit, update, commit, rollback, or close. By default, local cache is used for the whole session duration. This cache is needed to resolve clear references to speed up the repeated nested queries, so it can never be completed disabled. But you can configure the local cache to be used just for the duration of a statement executed by local cache scope equals statement. Note that when the local cache scope is set to session, MyBatis return references to the same object which are stored in the local cache. Any modification of the return object, list, etc. influences the local cache contents and subsequently the values which are returned from the cache in the lifetime of the session. Therefore, as best practice, do not modify the object returned by MyBatis. You can clear the local cache at any time by calling void clear cache. Now we are considering ensuring that SQL session is closed. The best way to ensure this is to use the following unit of work pattern. With close, the most importantly thing you must ensure to close any session that you open. The best way to ensure this is to following the unit work of pattern. Just like SQL session factory, you can get the instance of configuration that session is used by calling get configuration method. The following 3 lines are pseudocode for doing some work. Now we are considering using mappers. The following example class demonstrates some method signatures and how they map to the SQL session. The various insert, update, delete, and select method are powerful. They can also be very verbose, not type safe, and not helpful to your IDE or unit test as they could be. You have therefore, a more common way to execute map statement is use mapper classes. The mapper class is simply an interface which method definitions that match up against the SQL session methods. For example, class demonstrate some method signatures and how they map to SQL session. In a nutshell, the mapper method signature should match the SQL session method that's associated to but without string parameter ID. Instead, the method name must match the mapper statement ID. In addition, the return type must match the expected result type for the single result or an array of collection for multiple result or cursor. All of the usual types are supported, include primitives, maps, pojos, and Java beans. Note the mapper interface do not need to implement any interface or extend any class as long as the method signature can be used. Uniquely identify the corresponding map statement. Mapper statement interfaces can be extend other interfaces. Be sure that you have statement to appropriate namespace when using XML binding to a mapper interfaces. Also, only limitation is that you cannot have same method signature in two interfaces in a hierarchy. A bad idea anyway. You can pass multiple parameters to a mapper method. If you do, they will be named by a literal param followed by their position in the parameter list by default. For example, hash param 1, hash param 2, etc. If you wish to change the name of the parameter, multiple only, you can use the @param param name annotation on their parameter. You can also pass as a row bound instance to the method to limit query results. Now we are considering SQL builder class. The solution here, for example, problem above look like this when rewritten with the SQL classes. The class SQL, this is in the package MyBatis.jdbc. One of the nastiest things the Java developer will ever have to do is embedded SQL in Java code. Usually this is done because the SQL has to be dynamically generated, otherwise you could externalize it in a file or a stored procedure. as you have already seen, the MyBatis has a powerful answer for dynamic generation in its XML file, XML mapping features. However, sometimes it becomes necessary to build SQL statement string inside the Java code. In this case, MyBatis has one more feature to help you out before reducing yourself to the typical mess of the plus signs, quotes, new lines, formatting problems, and nested conditional to deal with extra commas and uh, 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 and conjunctions. Uh, Indeed, dynamically generating SQL code in Java can be a real nightmare. For example, here the solution, MyBatis 3 offers convenient utility class to help with this problem. With the SQL class, you can simply create an instance that lets you to call methods against it to build SQL statement one step at a time. Example problem above would look like when written with SQL class here. When what is so special about that example? Well, if you look closely, it doesn't have to worry about accidentally duplicating n keywords. Uh, 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 or choosing them where and or none at all. The SQL class takes care of understanding where needs to go and should be used and all of the string concatenation. Now we are considering SQL class. Here are some examples. Here delete from method start delete statement and specify table to delete from. Generally this should be followed by where statement. Where string appends the new where clause condition concatenated by and can be called multiple times, which causes it to concatenate new conditions each time with and, or use or method to split with an or. Insert into string, start and insert a statement and specify table to start into. This should be followed by one or more values method or into column method or into values calls. Values method appends and insert statement. First parameter is the columns to insert, and uh, the second parameter is values. Select strings start or appends the select clause, then can be called more than once, and parameters will be append to the select clause, and parameters are usually comma separated list of columns and aliases, but can be anything acceptable to the driver. From string start or appends to a from clause can be called more than once, and parameters will be append to the from clause. Parameters are usually a table name, an alias, or anything separated to the driver. Order by string appends a new order by clause elements concatenated with comma, can be called multiple times, which causes it to concatenate new conditions each time with the comma. Delete from, start the delete statement and specify a table to delete from. Generally this should be followed by where statement. Update string start an update statement and specify the table to update. This should be followed by one or more set method calls, and usually where method call. Set append a set list to update statement. Note, it is important to note that SQL class writes limit offset in and rows. Fetch first and rows only classes to generate into the generated statement as is. In other words, the library does not attempt to normalize those values for a database that don't support these clauses directly. Therefore, it is very important for users to understand whether or not the target database supports these clauses. If the target database does not support these clauses, then it's likely that using this support will cause SQL that has runtime errors. Anonymous inner class here. Builder fluent style. With conditionals, not the final parameter required for anonymous inner class to access them. Now we are considering SQL builder and select builder deprecated. Before version 2. Deprecated, this allows us to create methods like this. Select builder is in package org.apache.mybatis.jdbc, and SQL builder is in the package org.same package org.apache.mybatis.jdbc. These are deprecated. Use the SQL class. Before version 3.2, we took a bit of a different approach by utilizing a thread local variable to mask some of the language limitations that make Java DSLs a bit cumbersome. However, this approach is now deprecated as modern frameworks have warned people the idea of using builder type patterns and anonymous inner classes for such things. Therefore, the select builder and SQL builder classes have been deprecated. Following methods apply to only deprecated SQL builder and select builder classes. Begin these methods clear the thread local state of the select builder class. reset method begin or reset. These methods clear thread local state and builder class and prepare it for new statement to be built. Begins reads the best when starting a new statement. Reset method reads the best when clearing a statement in the middle of execution of some reason, perhaps if the logic demands a complete different statement under some conditions. SQL, this returns the generated SQL and resets the select builder state as if begin method or reset method call. Thus this method can only be called once. Select builder and SQL builder classes are not magical, but it's important to know how they work. Select builder and SQL builder use combination of static imports and local thread variables to enable the clean syntax that can be easily interlaced with conditionals. Use them for use statistically import the method from classes like one or the other, not both. This allows us to create methods like this. Deprecated, clears the thread local variable. Exception example, we can consider this occurred in Spring and MyBatis. Java.land.illegal argument exception mapped statement collection does not contain value for com.thong lm1.spring.mappers.order.mappers.get all order at org.apache.ibatis.session.configuration $strictmap.get configuration.java 672 org.apache.ibatis.session.configuration.get mapped statement configuration.java 5 or 6 at etc. As an error example, we can consider this. Mapped statement collection does not contain value for mapper .batch customer .find batch customer 1-to-1. Now this is the end of my presentation. Thank you very much for watching it.